What have the Moore steering group been up to? Well, lace up your boots.
Here we have the Moore car. It is a modular research vehicle, which consists of 3 possible modules, a front, center, and a rear, with there being multiple variations of the front and rear. This gave our group the challenge of designing proper steering geometry for different modules. Before we could even start assessing the steering of the Moore car, we had to research steering geometry, scan and draw new 3D parts, and further the CAD assemblies of the car in SolidWorks. The rest of the video will break down our process and some results. To assist in creating a 3D drawn car and to draw complicated and accurate parts, we used a 3D scanner. The resulting STL files were changed into 3D CAD parts and were later used in some SolidWorks assemblies as seen here. Furthermore, our client asked us to investigate a condition called bump steer. This can be caused by incorrect alignment of the steering and suspension components. This results in the steering wheel turning in response to bumps or ruts in the road. Therefore, we had to minimize this unsafe situation. We managed to do it by making sure the tie rod is parallel to the lower wishbone, as well as placing the steering rack in the optimal position. We did take this in our design and made a small simulation of it in SolidWorks. To know exactly how much the steering wheel would rotate in response to bump steer, the client asked us to measure the steering wheel to wheel turning ratio. We accomplished this with a sheet of plywood and drew lines of degrees on it, then laid the plywood underneath the tire. We rotated the steering wheel 1 full turn and recorded a tire turn of 36 degrees, so a 1:10 ratio. Using these simulations, we determined if the car went over a bump of 15 centimeters, the steering wheel would rotate almost half a turn, which is significant. Later in the project, the client decided to change the front module for a longer one. Their plan was to place the rear torque vector frame up front. This decision bids well for decreasing bump steer because it allows more space to better place the steering rack and tie rods. We of course assessed the bump steer in this new module, plus as a request from the client we assessed Ackerman's steering. Ackerman's steering determines handling and turning radius. We can draw the instantaneous center of the wheels when straight or aligned as seen in the first and second images. We were able to draw then measure the Moore car's instantaneous center seen in the third image. We tested this in SolidWorks by measuring all the angles when the steering rack is moved by 5 mm. Then we simplified it in a sketch using some lines. Here you can see that the part of the rear steering system a bit off. This is because the steering rack is in the opposite direction than what should be, which causes that the Ackerman principle works the same way as in the front. This should be mirrored. We conclude together with the client that there is no better option on the vehicle than leaving it like this.
So, there you have it folks, an assessment of steering geometry for different front modules and with varying positions of steering components. Sure hope you enjoyed this video and see you next time.